Okay, in this lesson we are going to take geometry and put it onto the coordinate plane. Okay, we're going to focus on two formulas, the distance formula and the midpoint formula. Both you've already seen in Algebra 1, but we're going to maybe take it and expand a little bit on it this semester in geometry. So first off, a quick refresher on some terms on the Cartesian coordinate plane. So this is our graph, our grid, our XY plane, Cartesian coordinate plane. So first off, we've got two axes. We've got an x-axis, the horizontal axis, and y-axis, which is our vertical axis. We've got a scale along both axes that shows us how much each tick mark counts for. So in this case, every tick mark, every grid mark is 1 on both our x and our y-axis. We've got 4 quadrants that are formed by the two axes, quadrant 1, 2, 3, and 4 in the bottom right. The intersection of the two axes is the origin, which its address is 0, 0, or its coordinates are 0, 0. Any other point in the coordinate plane has an address or has coordinates in relation to the origin. So for example, point A here in red has coordinates 4, 6, because from the origin, if we go to the right 4 and up 6 units, then we'll land on that point. Okay, so a positive x coordinate means we're going to the right. A positive y coordinate means we're going up. Okay, if we look at point B, which is at 2, 2, if we go from the origin to the right 2, because it's positive, but now we've got a negative y coordinate, which means we want to go down 2. So right 2, down 2, we'll end up at B. And point C is in the second quadrant. So if we go from the origin, if we go over 1, 2, 3, 4, 5, then we'll be in line with our C point, but it's a negative 5 since we went to the left instead of the right. So we got negative 5, and then we go up 2, which gives us a positive 2y coordinate. Okay, so that's our Cartesian coordinate plane. Now, let's look at the distance formula. So, distance formula, we use a lowercase d, set that equal to our square root of, in parentheses, x2 minus x1 squared, plus, in parentheses, y2 minus y1 squared. Okay, so that's our distance formula. We've got a radical, we've got some subscript numbers, we've got some superscript exponents, we got a lot of things going on. So let's break it down. First off, our x1, x2, y1, y2 comes from the 2 points that we're trying to find the distance between. So for example, if we want to find the distance between points A and B on our coordinate plane, then we're going to take point A, which is at 4, 6, and point B, which is at 2, negative 2, and assign them these x and y values. So the x coordinate of point A, since it's our first point, we're going to call it x1. The y coordinate, we're going to call it y1. For our second point, we're going to call the x coordinate x2, second coordinate, the y coordinate, y2. Okay, so now that we've got each of these numbers assigned to one of our variables in our formula, we can just plug them into our formula. So this is what makes the distance formula nice. We just assign values, plug them in. So distance formula, d equals, in place of x2, we've got a 2. In place of x1, we've got a 4. Notice that we're subtracting inside the parentheses, adding in between. Okay, so square that plus the difference of negative 2 and 6. Square that. Okay, so remember your PEMDAS, your order of operations. You want to simplify what's inside the parentheses first before you do any squaring. So 2 minus 4 is a negative 2. Negative 2 minus 6 is a negative 8. Any negative number squared is a positive number, since a negative times a negative is a positive. So negative 2 times a negative 2 is a positive 4. Negative 8 times itself is 64. So now we got rid of the parentheses, we got rid of the powers, so now we've got 4 plus 64 is 68. We've got the square root of 68. Now in simplest radical form, we want to simplify this radical. We don't want to leave any radicands, the number underneath the radical, that have any perfect square factors. So we want to break it down. 4 is a factor of 68 because 4 times 17 is 68. So we want to factor it. 4 times 17 replaces 68. The product property for a radical says that we can split that into two separate radicals. So the square root of 4 times the square root of 17 is equivalent. We know the square root of 4 is 2 because 2 times 2 is 4. So we can simplify that. So 2 times square root of 17, 17 is prime, so we can't simplify that anymore. So AB, which remember denotes the distance between A and B, which is what we're looking for, is 2 times the square root of 17. Okay, if you're asked for a rounded version or a decimal value, then you can just put that into your calculator, square root of 68. Okay, next up, midpoint formula. Midpoint, we sometimes use a capital M to denote the midpoint, to name it. Here's our formula. M equals x1 plus x2 divided by 2, comma, y1 plus y2 over 2. Now this is a little different formula. It uses the same variables as we use in the distance formula, but because we're looking for a point, we're going to have two separate numbers. We're going to have our new x-coordinate for a midpoint and our new y-coordinate. That's why we've got that comma in there. So you can think about the midpoint formula kind of as two mini formulas inside of one. Okay, so first example, let's say we want to find the midpoint of segment AC. All right, so let's take our points A, find its coordinates, point C, find its coordinates. Sometimes you'll be given these, sometimes you'll be given a graph. Go ahead and label them just like we did with the distance formula. So x1, y1, x2, y2, and then plug them into the formula. Just like with distance formula, plug them in, simplify, see what you get. So let's plug them in. We've got 4 plus a negative 5 over 2. 6 plus 2 over 2. Simplify that. So 4 and a negative 5 is a negative 1 over 2. 6 and 2 is 8 over 2. Well, we know 8 divided by 2 is 4, so we want to go ahead and simplify that. We don't want to leave any fractions that we can simplify in our final answer. So negative 1/2, 4 is the midpoint. If we find that on our graph, negative 1/2 up 4, will be right about there, and it looks right in the center of A and C, directly in between them. Okay, good. A second example, a little tweak to this problem, says the midpoint of segment BD, so now we're looking at point B and then some D that we don't know what it is M, which is negative 1, negative 3. Find the coordinates of D. Interesting. So in this problem, we know one of the endpoints. They give us the midpoint. They want us to find the other endpoint. So in the first problem, we were looking for the midpoint if we knew the two endpoints. This problem, we know the midpoint already, but we're missing one of the endpoints. We're going to set it up the same way. So starting off using our midpoint formula, plug in what you know. Well, we're told what our midpoint is, so plug that in for M. So negative 1, negative 3 on the left side of the equation. We know that one of our endpoints is B, so we can call that x1, y1 for 2 and negative 2, the coordinates of B. So plug those in for x1 and y1. We don't know the coordinates of D, so let's just leave those as x2 and y2. So our formula, once we substitute those 2 points in, is going to be negative 1, negative 3 equals 2 plus x2 over 2, comma, negative 2 plus y2 over 2. Now remember, back up here when I said there were two kind of mini formulas inside of the midpoint formula, this is where keeping that in mind comes in handy. We want to separate these two mini formulas. So our x-coordinate, negative 1 of our midpoint, equals whatever this is going to simplify to. So take just that first part of each side of the equation and make it its own equation. So negative 1 is the same as 2 plus x2 over 2. Do your algebra, solve for x2, so we're going to multiply both sides by 2 to get rid of that fraction. Negative 1 times 2 is negative 2, which is equal to 2 plus x sub 2. Subtract 2 from both sides to get that x2 by itself. x2 equals negative 4. So that's our new x-coordinate for our point D. Still have to find our y-coordinate though. So now let's take the y-coordinate of our midpoint, set it equal to the y-coordinate half of the midpoint formula, negative 2 plus y2 over 2. Do your algebra, solve for y2, we get negative 4 for our y-coordinate. So, point D, we found out that the x-coordinate is negative 4, y-coordinate is negative 4. If we plot that on our coordinate plane, looking at negative 4, so left 4, down 4 from our origin, that's point D. And if we look at our midpoint, which was at negative 1, negative 3, that looks like our midpoint is right in between D and B.